everybody. Welcome to AWS's first ever security conference, Inforce. I hope you're having a great time here in Boston. So I took this snapshot. A couple months ago of our AWS Management Console. This is the list of services that you can navigate to in our console. This is not a short list. It grows, in fact, it has grown since I took this screenshot 2 months ago. And you're here at our first ever security conference for security-minded builders here at AWS. And I wouldn't blame you if you looked at a list like this and your job is to, help your organization use the cloud securely. If you look at a list like this and think this is a really daunting task. This is a lot of surface area to secure, isn't it? Well, I'm here with good news for you, because it's true. This list is really long and it's going to keep growing. But there's really, if you want to secure an AWS cloud environment, which is presumably why you're all here, there's really only, although there's a triple-digit number of AWS services now, there's only a small handful of what I'm going to call fundamental patterns that repeat over and over and over again across all of our services that, if you know how to do them, if you know how to recognize them, if you know what to look for, you can actually be very effective at securing all of these services. So you learn a few patterns and you're able to secure all of them. You can see up here what we're going to talk about here. We're going to talk about permissions, we're going to talk about encrypting your data, we're going to talk about securing your network connectivity, and we are going to put the fun in cloud security fundamentals. There you go. Okay, well, so what this is here, this talk here is for builders. This talk is going to be all practice and almost no theory. We're going to focus very directly on these 3 fundamental patterns and what you need to know in order to secure your cloud environment with them. For each of them, I'm going to give you a quick 411 on what they are and why you care about it, and then we're going to go right into the details of how you use them. And my goal is, when you walk away from here, when you go back home, when you leave this beautiful city of Boston in June, and you go back to wherever it is that you came from, the goal here is to accelerate yourself as you go back and help your organization use the cloud securely. Because, we're not going to talk about every single service that you use. Rather, we're going to talk about the patterns. You're going to come away from here knowing what to look for. And the rest will be details that you can fill in. All right, we're ready to get started? All right, IAM. If you really, of these 3 patterns, if you know nothing else, this is what you need to know to secure your environment. IAM, Identity and Access Management in AWS. Okay, so the 411 on this is authentication and authorization in AWS. The I stands for authentication and the AM stands for authorization. Identity, access management. And why do you care about this? Well, you care about, no matter what you're doing in AWS, you care about this, because the WS in AWS stands for Web Services. You reach all of our services via API, and these APIs are authenticated and authorized. This is how you grant entities permission to make API calls on behalf of yourself in AWS. So we're going to give you sort of the quick primer on what you need to know here to be effective. And I'm not going to lie, a lot of IAM is just knowing how to look at the documentation, knowing what the patterns are to apply, and knowing what to look for in the service that you're using. So that's what we're going to go after today. So we're going to learn how to read and write these policies. Okay, so first of all, let's talk about the identity half of this. If you've ever logged into AWS using a username and a password, you did something like this, you are an IAM user. That is one kind of identity for humans that we have in AWS. These are long-term credentials. You also have long-term programmatic credentials that I'm sure many of you have interacted with. This is one possible identity for humans in AWS. You might hear me use the word IAM principal. An IAM principal is an identity in IAM. It's somebody who can make calls. So an IAM user is a principal. You might hear me use the word principal. Another way human beings can get into AWS, I'm not going to cover this topic in depth here, but you might have, if you're at a large enterprise organization, you might have seen this mode of getting into AWS. You got your own corporate directory, like a Microsoft Active Directory or something like that, and you are signing into that, and then being federated is the word, into AWS, landing in not an IAM user, but an IAM role. It's a different kind of principle, and a federated role is another way that a human being could have an identity in AWS from which to make calls. And then there are also IAM roles for I just put 5 things up here, but a large number of AWS services, especially our various compute environments, EC2, Lambda, ECS, a whole lot of others, can themselves have IAM identities. Because if you think about it, you're running a serverless application on Lambda, you're running an application on EC2 instances. Nearly everything you do is going to be making API calls against AWS services, and is going to need an identity, to be authenticated as to make these calls. So that's another kind of identity in AWS. Also an IAM role, also an IAM principle, but an identity for non-human applications. So all of these environments, they have the ability to have roles, and the nice thing about IAM roles, and again, this is all mostly taken care of for you under the hood, they operate with short-term credentials. As security people, you should like to hear those words, short-term credentials. So this is who you can be in IAM, and in fact, on this role topic, if you were going to walk into the AWS console, the IAM console, and go to create a role, this is the first thing you would see here. The first choice you would have is, what is this role for? And you see there's 4 options up top. This first one is for your application, and you see there's a whole long list below of the various kinds of environments your application might be running on. EC2 and Lambda being the most common choices, so those are up top. Roles are also, we're going to talk about this in a little bit later, but roles are also how you grant access into your account from outside your account. We'll talk about that a little bit later. You also use IAM roles for that. And then finally, federation, like we showed you before, for human identities from various kinds of identity providers, web identity providers and SAML identity providers. So that's how you make a role. Those are the options for what a role can be. And I just want to say a couple of words on how authentication works in AWS. Again, I promised practice more than theory, but just so you understand how this works. The fact of the matter is you don't need to know, because almost except in very exceptional use cases, you're going to be accessing AWS either through the console, through one of our many programming language SDKs, or through our command line interface. All the authentication stuff's going to be done under the hood for you. But the way this works is you have a pair of credentials, a non-secret part called the access key ID, a secret part called the secret access key, and your API call is going to be authenticated by signing the request, an HMAC signature of the request with the secret key. When you submit it to the service, then the service is able to authenticate it. Actually, if you're curious about this, what I would do is just look at the actual HTTPS request that gets sent to an AWS service when you make the API call. If you're curious how that looks, and you'll sort of figure it out. But who you are is only half the story, right? The other half of it is authorization. Now that we know who you are, and that it's actually you making this API call to say S3, what are you allowed to do? And now that's where policies come in. In order to be allowed to do something, to make any kind of request in AWS, you have to have a policy that gives you permission to do so. Well, so we have a number of pre-canned, this is in the policies pane of the IAM console. We have a number of pre-canned policies. They have, human readable names. They're sort of self-describing what they do. And I would actually, these are really useful for setting up permissions for human roles that have common sets of fairly coarse-grained actions that they want to do. It's actually probably worth your while if you're trying to learn, and if you're someone who likes to sort of learn by looking at the details. That's how I like to learn. I would actually, you can look at how these policies are written to sort of get an idea of what these services do. I actually find that to be a very useful way to learn about what a service does, is to go look at its, look at its managed permission policy and get an idea of what kinds of permissions it needs. But a lot of the time, and especially for writing your own applications, you're going to want to go finer grained than that. And that means you're going to need to learn how to read and write an IAM policy. Now, the fundamentals of reading and writing IAM policy are fairly straightforward. Again, repeatable patterns. And whereas each service has different kinds of conditions and actions that they support, really the patterns here, if you learn them, you're going to be able to take our docs and write a good policy. So here was about, aside from a policy that just grants all access to everything, this was the simplest policy I could think of. Okay, so what's going on here in this policy? All right, well, all statements, and the policy has one or more statements. All the ones I'm going to show you here have one statement, but they could have multiple. All right, so first off, all of these statements are going to have an effect. The effect is either going to be allow or deny. It means what you think. Actions, you're going to have one or more actions, and these actions can be wildcarded. So what this means here is this means all actions in DynamoDB. And then finally over here, what can and can't you take that action against? And here I wildcarded that. And what this means is that whoever has this policy attached can do anything in DynamoDB. So this would be an appropriate role for maybe like this would be an appropriate permission for, say a human whose job it is to, look after all of the DynamoDB tables in an account. Okay, well, you're security people, you probably want to get a little bit more granular than that. Well, let's say I was going to be writing an IAM policy for an application that I'm writing. Maybe this is going to be an application I'm going to run, a serverless application I'm going to run on Lambda that needs to, read a bunch of things out of a DynamoDB table as part of doing its job. This is going to be the policy attached to the role for the Lambda function. Okay, so, I know a couple of specific actions that I wanted to do. Batch get item query, that's pretty much how you read things out of DynamoDB. There are a couple of other actions that also do that. But if I know these are the actions I'm taking, I can make it a little more specific. Hey, you know what? I can make this even more specific. What I could do here is, you notice here now I'm being specific about the resource. So what's going on here, what's different here is, first of all, this notation here is called an Amazon resource name, an ARN. And you see it's got the service name, the region, it's a fully qualified name. And I'm being very specific. I'm saying this application, I know it's trying to read my table name. I might have other tables in my account. The application's not going to read them, so I'm giving it specific access to this table. You'll notice I actually have two resources here. Now, why is that? Well, that's because if you go and look, and I'll show you the documentation page in a couple of minutes. If you go and look at the documentation for how DynamoDB does policies, there'll be a big table. We have a big table like this for every service, and you'll see that for query, DynamoDB queries involves both the table and the index that you're querying. So I'm saying both the table and any index under the table is queryable by my application. So that's how one of these fine-grained policies works. Want to see more policies? All right, here's another one. This one has something new. Okay, so this is a different service that we're talking about here, Secrets Manager. If anyone familiar with Secrets Manager, it's a way to securely store your secret data and protect it with permissions in AWS. A way that you no longer need your developers handling the secret material themselves. Okay, so get secret value, that's how you get the value underneath the secret. So this is giving someone permission to look at the secret. Saying star for the resource, any secrets in the account, but I'm adding this new thing, which is a condition. And this condition, if you look at this for a second, you can kind of figure out what it is saying here. What it means here is secrets have tags on them. Tags are a way of attaching attributes to items across AWS. So Secrets Manager supports tags. So if I tag my secrets with a project, it needs to match the you can also tag IAM principals like users and roles with tags. So the project of the caller has to match the project of the secret. So that's what this policy means. And so that's what it means. And in fact, it's attribute-based access control, right? What this means is that people working on people tagged with the red project can read the red secrets, and people tagged with the blue project can read the blue secrets. And so this is a really useful way to segment groups of things in your account so that different groups of people have access to different groups of things, attribute-based access control. Okay. So how did I figure out how to write all those policies? We got a lot of services, they do a lot of things. There's a lot of conditions available across these different services. Well, this is my favorite page of the AWS documentation. Actions, resources, and condition keys for AWS services, because along the left rail here is a full list of all of our services. And for each of these, there's going to be a table that has a row for every action, tells you what kinds of resources you would put in the resource field, and then tells you what kinds of conditions you can specify against those resources. So you take the pattern you just saw, go look at the documentation page for the service that you're using, and you can apply this, and you can write a fine-grained permissions policy for anything that you're doing. Now, in an AWS enterprise environment, it's often the case that everything we've talked about so far is for permissions within a given AWS account. Now, those of you who work at enterprises, even those of you who work at smaller businesses, you're probably aware of the fact that in reality, you're often working across multiple AWS accounts, sometimes a small number, sometimes a very large number in your organization, and you're trying to secure the cloud across all of these accounts. And you got different groups of people with different permission levels to different accounts. Some of these accounts, these accounts will have different security posture than others. Some accounts are for people's science experiments. Some are for your, extra secure customer data. These accounts are all different, and yet you need to secure all of them. And you'll often find that it's the case when you're working across accounts that you're in situations where some principal from one account needs to get at some resource, like an S3 bucket, in another account. Okay, so how do I do this? Well, we just talked about how to write an IAM policy, right? So, okay, let me write a policy like this. Allow S3 get object, and I'll put the S3 object's ARN in there. Is this going to work? What do we think? Should this work? No. Because think about it, right? Why should I, over in that red account, over in the account on the left, why should I be able to write a policy that grants me access to somebody else's thing? Like, if I could do that, then I could just grant myself access to your bucket, right? And that's obviously not okay. So when you have two accounts involved in an authorization, you actually need it allowed from both sides. So this caller does need this permission because they're going to be calling getObject, and so they need permission to call getObject on this resource. But you also need something over on the bucket owner side that says that this account can come in. So that's where something called resource-based policies comes in. S3 bucket policies are an example of resource-based policies, but a double-digit number of our services support these on their resources. And what they are is they're IAM policy. They look like all of the patterns that we've been seeing before, but they're attached to the resource, like to the S3 bucket, and not to the principal making the call. All right, so you see over here we have a snippet of IAM policy over here. It's got one new thing in here, principal. We weren't looking at that before because all of the policies we had before were attached to a principal, so you knew who the principal was. But this bucket, you can kind of see what it's saying. It's saying, I will let anybody from account 111122223333 call getObject on any object underneath this bucket. Now you might be wondering, if as you're looking at this S3 bucket, you might be wondering what that root thing is, right? Maybe you've read somewhere that root is not something you should do in AWS. You should get rid of your root credentials. You should always be an IAM principal. That's correct. That's true. What root means here, what it means precisely, and again, I told you this is more practice than theory. I can give you a little bit of theory right now. If you don't understand the next part, it's okay. What this means, this resource policy, the principle in this resource policy, it's actually what it's doing is it's trusting this role, this account, to issue policies that give access. So that's very technically what it's doing. But in practice, back in reality, what a policy like this means is that, okay, I trust that other account, and anybody in that other account who has permission to call this bucket, they should be able to. So that's what this does. That's what this accomplishes in practice. So now we have two accounts involved. The principal says they can make the call. The resource says the principal can make the call, says that they trust the account to issue a principal for the resource to make, for the principal to make the call. And now this call is allowed. So that's what it takes when you're working across account. Both sides need to say yes. When you're getting an access denied when working across accounts, when you're troubleshooting, the first thing to look for is both sides. Okay, now a lot of our AWS services support resource-based policies, but some of them don't. For example, a DynamoDB table. What happens when a principal in this account needs to call a DynamoDB table in this account? Well, DynamoDB tables don't have resource-based policies, so there's another pattern you can use for cross-account access if you're going to do that. The way it works, create a role. Create a role right next to the resource in that same account. And like any other IAM role, we'll put a policy on it, and that policy, will look the way you expect. It'll allow, let's say we're trying to allow get item on this particular table. So now you know that anybody who's in this role can make get item requests against this table. Now, of course, how do you get into this role from over here? Well, IAM calls this a trust policy, but really it's another resource-based policy like the one you just saw in S3. What does this say? Well, this one over here says assume role. That's the action you take when you assume a role. I'm going to trust the root of this account. Again, I'm going to trust this account to say who can get into this role. So I'm going to trust this other account. Now the third leg of this is, of course, so this account seems to say that they can get in, but this account needs to as well. So we'll put a policy on this caller principal here, not saying anything about DynamoDB, but instead saying that they can get this role, can get into this role. So now with all of those things together, the way the access is done is this role assumes the other role, gets back some temporary credentials, because now it can be that role, and then using those temporary credentials, it makes the call to DynamoDB. So those are your two patterns for cross-account access if you ever need to do that. But still on this topic of multiple accounts in AWS, when you're working across multiple accounts in AWS, the service to look for, the service to help you with governance, to help you with control, to help you with security and variance across these accounts is AWS Organizations. Now at its most basic level, what AWS Organizations lets you do is it lets you organize your accounts into a hierarchy of organizational units. You've got, it's not pictured here, but you've got an administrative account that we call the master account that's in charge of the organization. You don't actually run any of your workloads in there. That account is just there for administration of the rest of the organization. And you can do a lot of really useful things. Now this talk is not really focused on organizations, but I just wanted to point out a couple of really useful things that you can do here. One thing you can do here, and this is especially relevant if you don't already have your own directory and federation provider and you're trying to manage human identities into an AWS organization, I would look at AWS SSO, our single sign-on product. SSO lets you create users directly in SSO. It can also integrate with a managed Microsoft Active Directory in your VPC if you have one of those. And what it lets you do is it lets you map users to access levels into AWS accounts, which gives you a nice way for your users to federate from one place into multiple accounts rather than having them juggle a lot of passwords or assuming a lot of roles all over the place. So it's a nice simplifier for that. But another thing that if you are working across multiple accounts, working with an organization, once you get to really understand these patterns of IAM, you're going to start to identify some what we'll call security invariants across your organization, things you just want to hold true everywhere. And if they're expressible in IAM policy, you can use something called a service control policy in your organization. Now what that is, it's a policy that applies for any principal anywhere under the organization making an API call. That policy is going to become part of the authorization. So if it has deny statements, if you just want to deny anybody from using certain regions, you would put that in your service control policy, and in every authorization, that policy would come into play. And a deny, if we encounter a deny anywhere in your policies, the action gets denied. So it's a good thing to know about as you start moving up a level. If your job is to secure an entire organization, go look at service control policies. And as a matter of fact, we just launched the ability to look at your historical usage of various services across your organization. That's in the IAM console. You look at the left rail, organizations. It's a good thing to look at as you're trying to figure out what service control policies to write. Okay, so that's what you need to know to do permissions on your cloud environment. Let's talk about your data, right? Because you're security people, you know that you should be encrypting your data. And our service for doing that is called KMS, Key Management Service. KMS, the 401 on that, it encrypts and decrypts. That's what it does all day long. And as a matter of fact, what you need to know, you don't even need to know how to do that, because in about, I just counted this morning, I think it was like 50-ish AWS services have integrations with KMS, where you can use KMS to encrypt your data, and the service takes care of all of the mechanics for you. So this is actually pretty simple, and I'm just going to go through kind of what really what you need to know is what you're looking for as you're using a service that's going to hold some of your data. Look for the KMS integration. I'll show you an example. Oh yeah, a little bit about how KMS works. You can tune out the next slide if you don't want a bunch of fiddly crypto stuff, but the thing is KMS has these two APIs, encrypt and decrypt. They can be used to encrypt up to 4K. Now you might be thinking, okay, 4K for encryption, and unless you're kind of, I don't know, unless you're kind of building the next Twitter or something, you might have chunks of data that are bigger than 4K, right? And the pattern that KMS uses for it, and again, we offer like client SDKs. If you're doing this yourself, you often don't have to do the heavy lifting. We'll help you with that. It's called envelope encryption. KMS will generate a data key for you, a symmetric key that you can use to encrypt your data. You can store the encrypted symmetric key along with your data, and then when it's time to decrypt it, you decrypt the symmetric key, so now you have the symmetric key, and then you can decrypt sort of the bulk of your data. That's how this works. The nice thing is that you didn't actually need to understand any of this because the service does it for you. So let me show you an example. I'm creating an S3 bucket over here, and you'll notice as I create the S3 bucket, I get asked a couple of questions about how to do the encryption. So default encryption, I'm like, yeah, I want my data encrypted in S3. There's a couple of options here. The first option here, SSE S3, that is encrypted with an encryption key that's managed by S3. That means I don't see it, I don't interact with it, I hardly even know it's there, except S3 is using their own keys to encrypt my data at rest. That's what SSE S3 means. I'm going to talk though about SSE KMS, the KMS integration, because that's the pattern that, that's the pattern you'll see repeated across many of our services. And you'll notice that I actually, if you do this, you'll notice you actually get two options here. You get a this AWS/service name key over here. That's the default, that's what these services call the default KMS key. That's a key that just automatically gets created in your account. It's got a policy on it that unilaterally grants access to all principals in the account, because the assumption is if you're using this key that you want everybody inside the account to be able to decrypt it. It's keys that are specifically to your account. And then you have this other option called a customer managed key, a CMK. There's another acronym that you might see. And a CMK, you give it the GUID, the identifier of a KMS key in your account. And if you want sort of fine-grained control over encryption, you might use that. You would tell KMS use that key, and then by default, all of your put objects will just automatically get encrypted by that key, and your get objects will automatically decrypt it on the way back. So you don't need to think about the mechanics. You assign the key, and S3 or any of these other services that integrates with S3 takes care of the rest. Okay, so really it all comes back to IAM policy. So over here, I've got a principal in my account. I've got a role. I got permission to call get object against this bucket. All right, and the bucket, the objects in the bucket were encrypted with a customer managed key. So what happens here? What happens here? Is this going to work? Raise your hand if you think it's going to work. Raise your hand if you think it's not going to work. Raise your hand if you knew that the only reason I would be asking such a question is if it wasn't going to work, and that's why you said no. You guys are great test takers, and I'm so proud of you. It is not going to work. Why won't it work? Well, okay, so when I make this API call to S3 to get object, well, you know, S3's first job is to authenticate the request. Good, it's me calling. Looks up my policies. The actual get of the raw encrypted bits from S3, I got permission to do that. Good. Now, S3 also is going to try to do a decrypt operation under my identity. In fact, if you look at your cloud trail, if you look at your audit log of calls, you'll see that that call was actually made by you, even though you never directly initiated it. We're going to try to make that call against S3. Guess what? This policy says nothing at all about KMS, right? And you know, the rules of IAM is that if I have a deny anywhere, it's denied. If there are no denies and I have an allow anywhere, it's allowed. And if nobody says anything about it, it's denied. Well, nobody said anything about KMS. I don't have permission to decrypt it. My get object is going to fail. How do I fix this? Well, the caller also needs to have permission to the specific key being used here. And now both of these calls are going to succeed, and again, S3 takes care of the decryption mechanics for us. The nice thing about that default key, that AWS/S3 key, is that you wouldn't actually need that because the key is unilaterally granting you access. But if you're using a customer managed key, just remember that for anybody who's going to read the data, needs permission not only to the original service, but also to the key to decrypt the data. That's really all you need to know to encrypt your data in AWS. Finally, we'll go into a slightly different topic, networking. VPC, Virtual Private Cloud. 411 on this is whenever you are running infrastructure in AWS, like your own applications, databases, other sorts of processes, your own infrastructure in AWS is going to run in this network called a VPC. And from a security standpoint, your concern is, you know, least privilege for connectivity, essentially. You want the connectivity that your applications need, that your infrastructure needs, and you don't want any other kind of connectivity. Because although you also have good security practices at your application level, and all of your services use TLS in order to talk to, even though you're doing everything else right, you also want to have least privilege at multiple layers. So that includes your network connectivity. So what builders need to know here, actually, networking, I found with my customers that networking can be sort of a daunting, can feel sort of like a daunting thing. It feels like a domain unto itself. The nice thing about VPC is it makes these concepts very accessible. Especially the security parts of VPC, they're quite straightforward and not that hard to wrap your head around. So let's do the Builders 411 on VPC. AWS, many regions around the world, adding regions all the time. And you know, if you work with AWS for a while, you know that we take our regional isolation very seriously. So, you know, you're talking to a service like EC2 in the EU West 1 region, our Dublin region, and you're talking to EC2 in, say, our AP Southeast 2 Sydney region. Sure, it's running the same software, it's the same EC2, but it's totally separate instances of that EC2 service. So we have these regions, they're isolated from one another, and these regions, within each region, we have further levels of isolation called availability zones. You may have heard us talk about that. It's basically us showing you kind of our fault domains within our region, separate data centers, separate power, separate networking, etc. We show you this so that you can spread your eggs across multiple baskets as you deploy into our network. So you can use this information to build for high availability. So what's your VPC? Your VPC is your network in a particular region, and you have control over a lot of things in the VPC, most notably the IP address range that your VPC sits on. So a very common IP address range to choose for a VPC, which we have done here, is 10.0.0.0/16. That's networking ease, classless interdomain routing notation for 10.0.something.something. That's what this IP range is. And as you can see, my VPC, it spans all of the availability zones because this is how I can run infrastructure in my network using all of these availability zones in the region. Now, further subdividing my VPC, I subdivide my VPC into sub-networks, subnets, sub-ranges of this IP address space. You'll notice that I called some of them private and some of them public. I'll explain what those words mean in a little while, but you'll see that these subnetworks, they exist, each of them exists within an availability zone. I have multiple of them, multiple within an availability zone, and they each carve out a space in my inside my VPC IP address range. And now once I have subnets, I can deploy infrastructure in there. And I'll tell you what I'm showing you over here. I'm showing you a service that has a network load balancer, a layer 4 load balancer, that's publicly accessible because I'm going to have my customers out on the internet calling my service, and they get load balanced to my application running on EC2 instances, and these EC2 instances to serve requests, they're querying a database, also in my network. That's what you're seeing here. Okay, so that's what goes in a VPC. All this stuff is my infrastructure, so it goes in my VPC. It has IP address ranges in my VPC. If you understand nothing else about VPC networking as a security person, I want you to come away understanding security groups and how to do them. It's a very straightforward concept. So what is a security group? A security group, for those of you with a little bit of network background, and don't worry if you don't have it, they're stateful firewalls. That's what they are. They have ingress rules, they have egress rules. They're stateful, so they track connections. If that didn't mean anything to you, it's fine. I'll give you an example. So here is my application that I just described to you. And there's actually, from a security standpoint, from a connectivity standpoint, there's really sort of three classes of things in here, three groups. I've got the load balancers, I've got the application running on EC2, and I've got the database. And each of these groups, like in English, I can kind of describe to you what connectivity I expect for each of these groups, right? The network load balancer, I want HTTPS traffic from everywhere because my customers are everywhere, so I want their traffic on that specific port. These EC2 instances, well, I probably want access, certainly need access on whatever port the application is running here from the load balancer. And you know what, I probably also have some other rules, like if I'm going to be allowing SSH access from bastions, maybe not in this picture, I have a set of SSH bastions, they're in a security group with that I'm allowing traffic in there. Databases, well, the databases are expecting traffic on, let's say they're running MySQL, so port 3306. They're expecting traffic from the application and maybe from any other processes that are running in my network or elsewhere that need to get into the database. Okay, so what I just described in words, those are your security groups. And that's how you do least privilege. You write groups about the ingress traffic that you're expecting, and that's pretty much it. So over here, for this first security group, I would write a rule that looks like this. And each of these groups, just for simplicity's sake, I'm going to give them only one rule, but you can have multiple rules, you can have many rules on a security group. And I'm showing you only ingress, inbound rules, but there's also outbound rules are also available if you're trying to limit what kinds of outbound connections things can initiate. These are stateful, and what that means is that if the connection was allowed in, it's tracking the connection, so the reply traffic, like the ACK to the SYN, is allowed to go back because the connection's already been established. Okay, so HTTPS port 443. I have this open to the world, 0.0.0/0. That's exactly my intention. I don't have other ports open, but I do have it open to the world. So the group that my load balancer's in, that's how it looks. Okay, what about these? These instances on which my application is running, I'm expecting traffic on my application port. Let's say it's 8443. I'm expecting traffic only from the group that the load balancers are in. So I can refer to this other security group by reference. I'm not trying to juggle a list of IP addresses here. So one security group can let in another security group. And then finally, the database is the same exact story, except they are letting in the EC2 instances. So always, whenever you're launching, so the pattern to look for is whenever you're launching something that's going to go into your VPC, the AWS service that you're working with is going to ask you about security groups. And that's a time for you to ask the question, okay, what traffic am I expecting in and on what port? And to write a specific security group for that and launch whatever infrastructure that is into that group. So that's the pattern to look for here. Okay, so that was, if you understood one thing, it was going to be security groups. You want to understand two things about networking? All right, we'll do routing. Okay? Routing, honestly, if you get your security groups right, your network is secure. Because security groups work, right? If you don't have an inbound rule for a connection and someone tries to initiate a connection to you, it's not going to succeed. But it is often the case that you want parts of your network to be what we call public and parts to be private. Now, don't get the wrong idea from the word public. The word public doesn't mean that it is exposed to the internet. It's not exposed to the internet unless you wrote a security group that exposes it to the internet. Rather, it has a route to an internet gateway. So, but let's start with these private subnets. What private means in this terminology is does not have a route to the internet, and the infrastructure down here does not have publicly routable IP addresses. It only has IP addresses that are routable within the VPC. So in VPC, we have this construct called a route table. A route table is simply a list of rules that packets match as they're getting routed. And you'll notice that this route table for my private subnet, it has only one rule here, and this rule is present on every subnet everywhere. It says 10.0.0/16, so that means traffic bound for my VPC, local. Anything that happens in my VPC stays in my VPC. You'll notice that there are no other routes in this route table, which means that anybody tries to send a packet to anywhere else, and it'll get black-holed because there's no route for it. If there's no route for it, it has nowhere to go. Okay, so what that means is that, I don't expect anything down here to initiate a connection to the world, or to even receive a connection from the world. And if they do, that traffic will be black-holed. So that's a good sort of second layer of network security protection. Now for my public subnets, I actually do want that second route because my network load balancers, I intend for them to be on the internet. So I have a second route here, 10.0.0/0, that means everything. And that traffic is gonna go to an IGW internet gateway. Internet gateway to the internet. With a route like that, anything in my public subnets that has a publicly routable IP address on it, the network load balancers do, can get back and forth to the internet. Now there's actually a third option I'm not going to talk about in detail here, but one you should know about if you're doing this, setting up public and private subnets. If the private subnets need outbound internet access, you don't want inbound internet access, there's a third option here called a NAT gateway. You can look this up in our documentation. It's very easy to set up. We manage network address translation, NAT, for you. If you know what that means, you can go and set that up. But you know what? There's a lot of AWS resources, a lot of AWS services that you're going to find aren't running in your VPC. I have a couple of examples up here, but actually lots and lots of AWS services. This endpoint that you call, like if you go and resolve the DNS name, like over here I've resolved the DNS name for CloudWatch logs. So that's where anytime I make a request through our SDK, through our command line interface, that's where the request is going. You'll notice that that IP address is not in your VPC. It doesn't start with 10.0. Okay, so how are we going to get connectivity to that from we just got through talking about how in our private subnets, there's no route to the internet. Right now, you can make a route to a NAT gateway, and that'll work. But you might reasonably ask the question: why do I need routability to the internet just to talk to my own stuff in AWS services? So, and this comes up all the time. For example, here on this picture, I'm running an application on EC2. CloudWatch offers this great agent that you can run on your EC2 agents that will just slurp up your logs from a location on disk and send it to CloudWatch Logs, where you can do all kinds of advanced analytics to it. It's really a great way to do your application logging. But of course, that agent is going to be making API calls to CloudWatch Logs, so without internet access, how's it going to get there? Well, the answer to that is VPC Endpoint. A long list of our AWS services support this mode of connectivity, and the way it works for nearly all of them, S3 and DynamoDB work a little bit differently than what you're seeing in this picture, but the effect is the same, and you'll quickly get the hang of how those work as well. But CloudWatch Logs and all of our other VPC endpoint services, except for S3 and DynamoDB, support. What they'll do is they'll plant endpoints which sit at IP addresses in your VPC. So therefore, now your local only route is going to work. It's going to get the packet there. And in fact, it even overrides the DNS name for CloudWatch Logs so that it resolves to these addresses. And so now when your CloudWatch Log agents is trying to slurp your logs into CloudWatch Logs, it's going to work. And like everything else that launches into your VPC, you get asked about security groups and subnets. So typically when I'm launching my VPC endpoints, I create a security group for them that allows typically the whole VPC access to port 443, right? Because I want my whole VPC able to talk to CloudWatch Logs, so that's the single rule I would write. And for a growing set, currently 13 of our VPC endpoint services, there's actually even an integration with IAM that works here. What this integration lets you do is it lets you use your network as a security perimeter. It's called VPC Endpoint Policies. So what I've done here, what you're looking at here, this is yet another IAM policy, except it's not attached to a principal, and it's not attached to a resource, and it's not attached to an organization, it's attached to a network. This is network as security perimeter here. And what you see here, now one thing you should know about this policy, I'm not granting access to anybody to do anything. This is a boundary. What I'm saying is the maximum permissions that can be obtained by anybody who calls CloudWatch Logs through this endpoint is this. So what is this doing here? Well, this got a new condition that you haven't seen yet, principal org ID. That means the principal must belong to this organization. And what this policy means that in this network, the only CloudWatch Logs calls that are going to get made are principals in my organization calling, log groups that are in this particular account. And you can hang all kinds of security and variants off of your network like this. It helps to keep them simple. But this is a very common one, where you say, like, I'm going to make sure that in this network, it's only the set of callers that I expect to be using my network. All right, so this kind of brings us to the end. So what do we talk about here? We talked about how you can learn a few patterns and secure everything in AWS. We talked about IAM, what that's for, how identities make AWS calls, and how to read and write their policies. Over here we talked about how you protect your data and how easy it is, like what you look for in these AWS services that are integrated with KMS. And then finally we talked about, if you know nothing else about networking, you know about security groups and routing now. So what I want you to do is go back home, use these patterns, apply these patterns to secure your environment. I hope you come away from here able to move a little bit faster on security than you were before. Thank you so much for coming out here today. I hope you have a great rest of the conference here. Thank you so much.